In this tutorial video, we're going to learn how to start scripting with DataKit. We'll take a look at connecting to the DataKit event system, creating and loading save points using Unity's UI system, and finally we'll make the game dynamically save and load our player data. Let's get started. We're using a pretty basic scene at the moment. We've set up a UI canvas with two UI buttons that we've labelled Auto Load Game and Auto Save Game. Right now they have no functionality, they're just positioned in the scene. At the bottom of the hierarchy you'll notice our 3D objects. We've got our camera, directional light, a ground object, and finally a fake capsule that we're using to simulate the player. If we press play in the editor, you'll notice the DataKit Freeloader feature kick in. This is very handy for development and testing. In any case, if we open up the hierarchy to take a closer look at the player capsule, we'll find that this is the only game object in the entire scene that has a custom script. This script is controlling the player's horizontal movement. You'll notice that the player is moving close to the edge of each side before turning back the other way. You may also notice the speed change every time it changes direction. Let's open the script to take a closer look at what's happening. It's important to mention that how this script works isn't really that important to DataKit at all. It's simply that we're using it to make the player move around, so it's worth understanding the code we're dealing with before we move forward. The script uses a few simple variables to control the player. First we have the default speed, then we have the maximum left position, maximum right position, and a boolean to track if the player is moving right or not. So in the update loop we have it separated into two parts. First we deal with if it's moving to the right. The first thing we check is if the player's X position is larger than the maximum right position, we've gone too far and we want the player to turn back to the left. In this case we set moving right to false, and we then randomize the player's speed to a value between 1 and 4. If we haven't gone far enough to the right yet, we can keep moving more towards the right using the current speed multiplied by delta time. The second half of the update loop deals with moving left. If we're not moving right and our player's X position is lower than the max left position, we've gone too far and we want to turn right again. Just like before, we toggle the moving right boolean and randomize the player's speed. If we haven't gone far enough to the left, we keep moving left using the current speed multiplied by delta time. So, now that we've broken down the only script in the scene so far, let's jump back to Unity and get ready to start implementing DataKit. The first thing we're going to do is have the two UI buttons tell DataKit to auto-save and auto-load our game. To do this, we're going to have to create a new script that we'll attach to the scene to handle the UI buttons. Let's do that now by creating a new C# script and calling it tutorial UI. Here we are in our new tutorial UI script. Let's get rid of the start and update methods as we won't be needing those. The next thing we'll need to do is add our namespaces. As we'll be working with Unity's UI system, we'll add using unityengine.ui. We're also using DataKit, so we'll also need to add using heltap.datakit. As we're going to want to access our UI buttons, let's add them to the script. We'll add a header just so things look a little nicer in the inspector, and then we'll add a reference for both the save and load buttons. Now that we've added them to the script, let's jump back to Unity. Next, let's add the script to the UI game object. We'll need to drag and drop the UI buttons into the variables we created in the script to make sure everything is set up correctly. Let's jump back to our tutorial UI script and get ready to integrate DataKit. To save and load data, we'll need to know if DataKit is ready or not. For example, we can't tell DataKit to save data while it's already trying to save data. DataKit will tell us it's ready if no other file operations are taking place. The best way of working with DataKit is to subscribe to its handy event system. So let's create the onEnable method and start subscribing to the events we're going to need. The first event we'll want to subscribe to is the onReady event. This will let us know every time DataKit changes from not ready to ready. We'll also need the onNotReady event. This will tell us when DataKit switches from ready to not ready. I like to separate my events with big comment headers to make the code a little clearer, but you don't have to do this. The next thing we need to do is make sure we unsubscribe from DataKit's events on the onDisable method. Let's copy and paste the existing code to speed things up. To unsubscribe, we simply change the plus sign to a minus sign. For us to receive these events from DataKit, we'll need to create callbacks for the onReady and onNotReady methods in our script. So let's quickly add them to the script so everything will work. For those of you who are new to working with events, these callback methods are going to be called by DataKit at the appropriate time, so we don't need to worry about building any complex update loops. In any case, we'll create our onReady method and our onNotReady method. Just to test that everything is working, we'll add a few debug comments to let us know if DataKit is ready or not in the console. So, let's go ahead and jump back into Unity and press play. We should see the DataKit is ready message right after the preloader finishes preparing DataKit. Sure enough, there's the message. You may have noticed some warning messages in the console. DataKit is just letting us know that because no data has been saved yet, it's using defaults. As soon as we save our data for the first time, those messages will go away. Let's get back to our script. Because the DataKit Freeloader feature guarantees that DataKit is ready before your scene begins in the editor, this may not always reflect the state of DataKit in an actual build. For example, depending on how you've set up your game, DataKit may not always be ready at the exact frame the scene begins. We can handle these possible timing issues by adding a little bit of extra code to the onEnable method. After we've subscribed to our events, we can test if DataKit is already in a readied state, and call the onReady method ourselves right away. It's also useful to assume DataKit is not ready before subscribing and handling any code there too. So, let's make our callbacks useful by removing our debug messages and controlling the UI buttons. We want to disable the buttons when DataKit isn't ready, and re-enable the buttons when DataKit becomes ready again. So let's do that now by changing the buttons interactable boolean. When DataKit becomes ready, our buttons become interactable. When DataKit is not ready, we disable the buttons interactable boolean. The next step is to create some public methods that will trigger when the user presses the buttons. We will need to create a method for when the user presses the Autosave button, and another for when the user presses the Autoload button. These are the methods we'll use to tell DataKit to save and load our data. It's always good practice to wrap these in a if DataKit is ready block, but this isn't strictly necessary. So if the user presses the Autosave button, we'll tell DataKit to autosave. If the user presses the Autoload button, we'll tell DataKit to autoload. Let's jump back to the Unity editor so we can hook up our UI buttons. First, we'll click on the Save UI button in the scene and add a new onClick event. Now we need to tell it what method to run. We'll tell it to use the UI game object where we place our script, and then we'll choose the onUserPressSave button method. Now, when the user presses the save button, it will call the method in our script, which will then tell DataKit to autosave. We'll do the same with the load button and test out the game by pressing play. You'll notice that in the DataKit debugger there are no save points in save slot 1, but if we click the autosave button we can see that DataKit is creating new save points. If we press the autoload button, DataKit is actually loading the newest save point, but we're not actually doing anything with the loaded data. We'll be handling that shortly. It's also worth pointing out how the buttons are dimmed while DataKit is performing file operations, and become interactable again once DataKit is ready. This is all happening from our script. In order for us to make these save points useful, we're going to make some additions to the player's custom script. We'll be taking advantage of DataKit's event system to get callbacks when a save point is about to be created and when new data has been loaded. It's also worth noting that we've already added the using helltap.datakit line to the top of the script. So, the first thing we need to do is subscribe to the DataKit events we need. Just like before, we'll set up the onEnable method, but this time we'll be using two new DataKit events. We'll be using the onSaveLocalDataStarted event, which is called just before local data becomes a new save point, and the onLoadLocalDataSuccessful event, which is called right after local data has been loaded successfully. We've chosen these two events because we're dealing specifically with local data. Just like before, we need to make sure to set up the onDisable method so we can unsubscribe from DataKit's events, as well as making callback methods for onSaveLocalDataStarted and onLoadLocalDataSuccessful. By the way, you can find a complete list and description of all DataKit events in the documentation PDF. For now, let's jump back to our script. We want our player script to save information about the player every time DataKit is about to create a new save point. For this, we'll be using the onSaveLocalDataStarted event. We're going to dynamically create some local data keys in order to save the data we need for the player. The first local key we'll make will be stored in a data group named tutorial player data. The name of the key will be called speed, and we'll simply pass along the speed variable that the script is already using. We'll create a few more local keys to the same data group. We'll add the moving right boolean of the script, as well as the position of the player that we'll grab from its transform component. Let's jump back to Unity and test out the changes. If we click into the local data tab, you'll notice that we have two default local data groups already set up. We'll simply hide these groups as they aren't relevant right now. You can see that when we try to create a new save point now, our script creates a new data group called tutorial player data along with the keys we just made. If we create a new save point, you can see the values of our local data keys updated by our script in real time. However, if we try to load the game, nothing new is happening. This is because we haven't finished setting up what should happen when new local data is loaded. Let's go back to our player script and finish setting up our onload local data successful callback. This method is fired as soon as DataKit successfully loads data. So let's try to grab those local data keys we saved and apply them back to the player. First, we'll update the speed variable by calling DataKit getLocalKey. Note that as this is a generic method, we need to specify the type of this variable so DataKit knows how to deserialize it. If you remember, the speed variable was a float, so we'll set that followed by the group name and the key name as parameters. Let's do the same for the other two keys. We'll copy and paste the first line to speed things up and make our changes. Moving right was a boolean, so we'll update the type and the name of the key. Lastly, position was a vector 3, so we'll also update this line too. We could improve this by checking to see if the keys already exist before trying to access them or by using default values, but for now this code should reset the player's position and movement settings every time a save point is loaded. Let's test this out by pressing play in the editor. When we press Autosave, our player script will now save the player's position, speed and direction to a save point. If we press Auto Load, DataKit automatically loads the newest save point and our player script resets the player's state. This video only scratches the surface of what is possible when scripting with DataKit. Please take a look through our documentation PDF to find out more. Thanks for watching.